All right, we're going to talk about section 5.4 of the book. And what this is going to use is we're going to talk about our identities. We're going to expand it a little bit to talk about some sum and difference. So adding and subtracting within value series. We can see we have cosine of alpha plus beta and cosine of alpha minus beta. Same with sine and tangent. And then these expand into our identities. So one thing to keep track of is our addition for cosine becomes subtraction. Addition for sine stays addition, and then subtraction for cosine becomes addition, and then subtraction for sine stays subtraction. So we're going to use these and apply these identities to solve various problems. One of them might look like this. We're giving a value of sine of 15. 15 degrees is not on our unit circle, and we're looking for an exact value. So what we want to do, our goal becomes, how do we take an angle measurement and then break it into either a sum or difference of known values? And by known values, we mean our unit circle values. So what we can see here is it's taken 45 minus 30. That's the same as 15. And that 45 minus, that's a subtraction identity with sine. It's going to break down into the identity that we just saw on the other sheet. And the advantage is 45, 30, 30, 45 are unit circle values that we can solve and that we know. And so it makes this a solution that we can figure out without using a calculator, basically by breaking down our unit circle values, where we know that sine of 45 degrees is root 2 over 2, cosine of 30 is root 3 over 2, and then we just do the math and combine our fractions to get our final exact answer. If we're to plug it into a calculator, we get the same, we get an approximate decimal value for that. All right. One that looks like this might look overwhelming, would be hard to figure out, but what we can see is this is actually just the sum identity for tangent, and so it breaks down right into those values. So we want to take, we have alpha and beta over here, up here we have 32 and 13, and so we can see is that translates directly into this, which thankfully is 45 degrees, which is a unit circle value. If this wasn't 45 degrees or some other unit circle value, we wouldn't be able to solve it from there. But since that identity allows us to break that apart, we can use the unit circle to apply it. All right. We might be asked to simplify to see what an identity looks like. So what we can see at the top here, right, is we have sine, sine, and then cosine, cosine. The angles are the same, x and 3x. And so what we need to think about is how is that one of the identities that we can have. So what we do to make this look exactly like our identity is we factor out a negative, which is going to flip the order. And then this becomes, the thing in the middle is our identity. And so what we can see is to add those angles for cosine, x plus 3x turns into the opposite of cosine of 4x. So that's just applying our identity, using those values to work through it, where we have the addition identity for cosine. And again, using your identity sheet, going back and forth, looking for those patterns will help you simplify and solve these problems. We might be asked to verify. That's kind of like a proof. Well, what we're going to do is we're going to take our left-hand side and then we're going to turn it into the right-hand side or vice versa. And in general, what we want to do is pick the side that's more complicated. So cosine of x is simple. There's something that we can do with this. We see that this is a subtraction of sine. So we apply the subtraction identity. We get sine of pi over 2 cosine x minus cosine pi over 2 sine of x. And then these are unit circle values. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. That times 0 goes away, and we're just left with cosine of x, which is our right-hand side. So we've taken that left-hand side and turned it into the right-hand side. That is verifying or proving that that identity works. All right. So let's say that we've been given something with an equation. So what we have is a trigonometric expression, we have an equals, and then we have just a value on the other side. And then we've been given an interval, so from 0 to 2 pi, because we have a lot of coterminal angles, we have to figure out, all right, where does this fall? So we're basically going to expand these with our addition and our subtraction identity for cosine. So this one here, the addition, turns into our values over there. And then we do the same thing with the subtraction ones. So we use our identifiers to simplify. And then we're going to hopefully we can get to an expression that we know the values to. All right, like that. So we know that that expands. And then these are unit circle values, which means we get an actual number there. And then thankfully, what we're going to see is I have a minus root 3 over 2 sine of x and a plus root 3 over 2 over sine of x, times sine of x, and those are just going to cancel. So my x's have dropped out. And now I have a half cosine of x and then another half cosine of x. 2 halves makes a whole, and we get to that value. All right? So now we have an equation, cosine of x is 1/2. We need to think about what angle measures are going to give us those values. So cosine of x being positive is going to mean that we are on our unit circle in either the first quadrant or the fourth quadrant. So those values of cosine are positive. And so we look at and try to remember which values give us cosine value 1/2. Those are going to be our root 3 over pi over root 3 and then 5 pi over root 3, which are going to be in the quadrants that we knew they were going to be. All right, so that's it. As you're going through these, again, think about how to simplify. Use those identities in their sheets. If something looks long and scary, see if it's something that we can just take an identity and transform into something that looks a little bit simpler to solve.